Welcome to The Cynical Developer, the podcast that helps you to improve your development knowledge and career through explaining the latest and greatest in development technology and providing you with what you need to succeed as a developer. Our sponsor JetBrains are here to help you fight against all types of memory issues in ASP.NET, .NET Core and .NET Framework applications with .memory memory profiler by JetBrains. Insightful views, Visual Studio integration, automatic snapshots, a command line profiler and a free unit testing framework. A free trial is available at cynicaldeveloper.com/.memory. In this episode, we talk about yet another testing paradigm, property-based testing with Mårten Rånge. Martin has been a programmer for many years, more than he would like to admit. And he is equally interested in functional programming as well as assembly programming. He occasionally blogs about functional programming and performance. Martin believes that reading existentialcomics.com once a week qualifies him as a postmodern philosopher-developer. Whatever that means. This is not Martin's first time on the podcast. We spoke to him back in episode 49, and that was about F#, which is one of his passions. And we're here today to talk about what I believe to be another of his. So welcome back to The Cynical Developer, Martin.
Thank you very much. I'm pleased to be here again. It's been a while, too long I think, but happy to be here.
Yeah. I think we're all busy people, and it is very hard to stay in touch with absolutely everybody, especially at the rate that this industry of ours moves.
Yeah, sure.
Cool. So what has changed since we last spoke on the show?
Well, I switched companies and I switched country. So I'm now living in Norway again. I lived in Sweden last time we talked.
Yeah.
Now I'm a Swedish citizen, but I lived in Norway before, and then I moved back to Norway, and I'm working at a company called Schibsted, which is a big company which nobody knows about. But we do big data engineering, and you might have heard about it, but GDPR is a big thing for us. It's really, really huge. So it's a very exciting times actually to be working with these things.
Yeah, being in the UK, I'm also affected by GDPR, and I think you're the first person I've spoken to that said it's exciting. Most people have said it's a pain.
I honestly think, and my team members are the same, we really are excited about this thing. This is a huge technical challenge and a legal challenge for us, and I think it's a good thing. You know, I want my data, I want other companies to take my personal data serious, and we are taking, your data serious, and we want to be even better, and we want to be in compliance with GDPR. So we are maybe not fans, but we are certainly thinking these are exciting times. But we're also thinking we could be in for a nuclear landscape where everything is sort of, all big data is gone. But we don't think it's going to be as bad.
Sure, yeah. It's a good thing. It definitely is a good thing from personal data point of view that everything should be better protected. I think it's the hoops and that we've got to jump through, and at the moment there's a lot of grey areas which I don't think are going to be ironed out 100% straight away. But it's definitely a step in the right direction.
Yes, and there are some areas which are certainly going to be in there, and that's what we're going to put in. The things we just know we're going to have, and then, as you say, things will sort of, after first lawsuits, sort of, settle down. We're going to know what this GDPR actually means.
Yeah, definitely. So we're not here to talk about GDPR, although it's a very hot topic at the moment. Yeah. We are here to talk about something that I don't know a great deal about. And it seemed like a very strange concept when it was first proposed that we talk about it, and that's property-based testing. So we're going to dive in straight away with what is property-based testing.
Yeah. So, I'm a big fan of property-based testing. I guess that's why I own. But I mean, if I'm going to give you the short sort of answer, too long didn't read. It's really a very simple idea with a somewhat frightening name. It's sometimes called randomized testing, but what you essentially do, right? And we're going to talk about different things, but what this boils down to is that you write a function that, given some input, returns that given that input to test your function, your code, And if your code behaves correctly, you return true. And if your code behaves wrong, you return false. And then what happens is that the property-based testing tool, like fscheck, generates thousands of different input. And your function should return true for each one of them. And if all of those return true, your property-based test passes. And that's essentially it, I think. And if you want to have a simple example, let's say I write a sorting function. Obviously, regardless of input, after I run my sorting function, the data should always be sorted. So I write a test function that, given an input, an array of input, run my sorting function, and then make sure that the output is sorted. And if it's sorted, I return true. That's a very simple property-based test.
Sure. So is this classed as a subtype of unit testing then? Or is it something different?
I would say it's often used in unit testing. And the reason for that is unit tests are typically high performant. And you need high performance when you're running thousands of test cases for each test. You can't, if you involve a database, you're probably talking minutes for each test case sometimes. That's not good when you're going to run thousands. So this is typically used with unit testing and sort of improve and write smarter unit tests. But I've been in situations where we have generated randomized test scenarios in a similar property-based testing manner. But I would say it complements unit testing.
Right, okay. So it complements unit testing, but you said that you would write the function first and then test it. So can you use it with test-driven development, or is this something that you do like tests after the development?
So, that was just my phrasing of it, but I think actually this enables us to do test-driven development even better. I'm not really a TDD expert. I will not try to pretend to be, but whenever I write TDD tests, I found that I have to write rather a lot of sort of tests to sort of box in my implementation and make sure I get something interesting out of it. What I do with property-based testing is I'm identifying some properties my code should have. For instance, after my function is run, the output should be sorted. That's one property. And I implement as a testing function, a property test function. And with property-based testing tool, I can, in my opinion, implement a far fewer tests than if I were doing a big classic unit testing. And I think it also gives better test codes. I think this makes testing development even better.
So could you look at it from a point of view of that this is lazy unit testing? Because if you were to do normal unit testing, put that in inverted commas, you would do your happy path, you would do your less than happy paths, you'd do your terrible worst day ever paths. I guess with this you do one path and then the framework does something for you.
Yes, I guess like you said, we have a happy path testing, and then you get different kind of sort of outliers to that happy path, and then you grow from that. And with property-based testing, I guess yes, that is what you're going for, really, right? You don't go for the happy path testing. You are defining a property that should hold that given any input, and then the testing framework will generate for you many different test cases that will sort of exercise many different paths in your program. You don't necessarily know exactly which paths, but because of randomization and because of smart randomization, it probably exercises more paths than what you would get if you would do normal unit testing, if that makes sense.
Yeah. So if I've got a function that takes in an integer, for argument's sake, as a parameter, I guess that this the property-based testing would throw at it a minus number, a positive number, a zero, and give you outputs based on that.
Yeah. And if let's say we take a string which has even more variance, right? So let's you say my function tests a string. Well, what do you get for phscheck, which is an example of a property-based testing tool for .NET? First, you get the empty string. That is the simplest thing. It usually gives you the empty string. Well, then it gives you a string with one character in it. Well, then it tries the null string. What can you handle null values? And then it tries more and more complex strings. Some of them are random, but some of them actually picked in order to sort of trip you up. It uses Unicode characters, it uses embedded nulls, it inserts SQL sort of injection things, all these kind of things that sort of maybe you should handle, but you didn't think about. And that kind of thing of smart randomization really helps sort of eliminating stupid bugs, I found.
Yeah. So I guess it's a little bit like Chaos Monkey that network and DevOps guys use, but this is for testing the actual code itself.
Yeah, I mean, yes, I mean Chaos Monkey. You try to your system is sort of you should handle failures. So let's fail something. Let's fail a service in your network.
Yep.
Your function should handle every input unless you specified it shouldn't handle some of them. So let's give you any input, but every input can be very exhaustive. It can be billions and billions of inputs, right? Well, it picks random input for you. You should handle all of those that it gets for you. And so I think that's really, I mean, it's not foolproof, but it gives great confidence after all the tests has passed.
Sure. So one of the main sort of points about writing tests rather, is that they're predictable, that you know exactly what's going in, you know exactly what should be coming out. So with here, we've got randomization. With this randomization, every time we run it, it's going to put in different inputs. So is it reliable enough to be using this every time that you build? Because I guess if you put inputs that the software doesn't deal with, it's going to fail that test. But then you go in, fail that piece of code, sorry. And if you go in and you fix that code to pass that test, but next time those tests run, because they're random, it doesn't test that same condition again. How can you be sure that it's always going to be testing correctly?
So several kind of different kinds of things I want to answer. Right. Let's say what I found when I use property-based testing is through randomization, the property-based testing tool discovers a very interesting corner case, which I didn't think about. What I probably will do then is saying, well, I want to make sure that this corner case always works, even though it doesn't show up in the randomization. So I will keep that corner case as a kind of normal unit test. So sort of keep that around. So always testing on that corner case. So property-based testing tool can help sort of dig out interesting test cases for you that you didn't think about. Now, and I think that's valuable. Now, when you have the build pipeline, you don't want the build pipeline to fail randomly. And with randomization, it feels like, well, that's a risk to that. But the thing is, if you implement a property-based testing tool and it fails, it identifies either problem in your code or in your test code. So that problem should be fixed. And so what you can do then is sort of, where you see from the traces on the failure that, okay, this is the test case, this is the input that failed. And then when you run this input, your test code with the same input, it should fail in the same way. And you fix that bug. Now, what also FScheck does, and the many other tools do, is they trace the random seed for you. So even though it's random, we are dealing with pseudo-randomness. So if you use the same random seed, it will always reproduce in the same way. But if you can't stand the thought of sort of having non-deterministic tests in your build pipeline, you're scared about this. Well, you can specify a random seed when you start a test case, and then it will always sort of execute in the same way. And that way you don't have non-deterministic tests in your build pipeline.
Sure. Okay. Yeah. The being able to rerun it based on the seed is a good idea. But so my next question, it's a bit of a loaded question, really. But do you really need to be developing for all the edge cases?
So, well, one of the reasons I write tests is I want to release my software with confidence. I feel confident that I haven't proved it works, but I feel confident that I probably can release this into wild and it doesn't do too much harm. When I write software with very limited input and no real consequences, it just fails and nobody's angry. I'm happy with less coverage. I don't really go for the edge cases. But when I write complex software with real consequences, like people are dying, or nuclear bombs go off, or bankruptcy, I don't write nuclear software. But I mean, imagine, right?
Yeah.
You're writing something which can go really horribly wrong. You probably want to sort of invest more in sort of going for the edge cases. I say the answer to your question, in my opinion, is it depends. But what's great with property-based testing tool, I think, is that I get this greater edge cases. I get more coverage of edge cases, not just code coverage, but sort of data coverage or like function coverage with less effort. When I write unit tests, I have anxiety that I don't come up with good test cases because I'm biased. I don't even think about test cases. When I use my property-based testing tool, I found that I write a lot less but better test cases that actually give me much greater confidence. And that is, I think, what's so important for me, that I can write better, less code that gives me more confidence in releasing my software.
How often do you profile memory usage in your .NET applications? What if you could automate that memory usage check so that you're executing that every time you commit a change? You can actually do that with .memory unit from our sponsors JetBrains. .memory unit is a free unit testing framework for monitoring .NET memory usage. You write unit tests that check your code for all kinds of memory issues and run the tests on your machine or on your continuous integration server, something like TeamCity or VSTS, just like you do with regular unit tests. You can track how much memory is allocated, check memory for objects of a specific type to prevent memory leaks, or compare several memory snapshots in a unit test to see if the memory usage is creeping up. Learn more and download .memory unit from cynicaldeveloper.com/.memory unit, or just search for a package called .memory unit on NuGet Gallery. Because it's trying all these different permutations of the method that you're testing. I guess it gives you is the word benchmark to go from. So if you run a property-based test against a method that has a lot of parameters input on it, and then it then takes hours because there's so many permutations. I guess that in itself is saying this is a code smell. You've done this wrong. You should be breaking this down to smaller functions as well.
Well, sort of as try to understand here, when you're running a test case, you don't call into your function directly the function you define. You're calling into a specific test function that is testing a specific property of your code. And that probably don't take so many parameters. It takes the parameter it needs to create the variance of your test run. But I think your concern here is very real, but in the reverse order, so to say. Because what happens with a proper-based testing tool like FSCheck is that it put a limit around 1,000 tests, and that's it. But what can happen if you're not careful is you run 1,000 tests, but you don't really get any confidence because the random input doesn't test the interesting part of the code. If I want to give an example, let's imagine you're writing a JSON parser, and one way to test JSON parser is you get random strings and you try to parse them. Most strings are not JSON strings, so it's good to test the fuzzing of your parser to make sure it handles those cases, but you're not hitting the interesting things about the JSON documents. Like most strings are not valid JSON, and if they are valid JSON, they're probably just an empty array or something like that. In those cases, you probably would like to apply something like defining a test model that describes what you want to test, a more complex test case. And it only includes interesting cases, this test model. When I say model, think of like a hierarchy of classes. Like you have a root class and that it has subclasses, sub-instances.
Okay.
Now, and then you randomize this model. If, for example, with the JSON parser, what I did before is that I created a document that described how my JSON document should look like, including white spaces. And then I generate a JSON string, which then is a valid JSON string. I try to parse it, and then I compare my parse document with the input test model. And that way I can hit interesting test cases rather than just, if you see what I mean, randomized misses, like, if that makes sense. Yeah.
So you can give it a data set to sort of pick from, if I'm understanding this right. So if it just took in an integer, would take it really, really basic, you could say that you only wanted to test it between -100 and 100. You wouldn't want to go into the full size of an integer at all.
Yes, that is one way to do it. But it could also be like you could say, give me an order document that contains all the rows, but only use amounts that are above 0 and not negative amounts for the order rows, things like that. And you're testing with that, so you are limiting the test input in some ways to make sure it makes sense to test.
Yeah, so it's like extra validation on it, where I think when we would write a unit test now, we would pass in, if it was an order, we would give it an order that had a value that we knew was going to be in the positive because it was an order value. But you can, rather than just that one permutation of that value, you could do however many different valid tests to continuously prove that.
Yeah, you write some kind of generator that generates randomly an order document that is valid, but it has a variance in it, and your code should work with any variance in it.
Right. Okay. So, tools. I think you mentioned one quite a few times already. Do I need these extra tools, or can I do it in some of the main testing frameworks that are out there already, like XUnit or NUnit or something like that?
XUnit and NUnit might have generative testing support. I'm not really an expert on it. It might exist. But what I would recommend your viewers, if they're on .NET, and I think maybe most of them are on .NET, is to check out something called fscheck, which has XUnit and NUnit adapters, so you can actually plug it into your normal kind of test framework. fscheck, I talked about F#. fscheck, comes from the functional domain. It comes from something called QuickCheck, but it has excellent C# API and excellent C# documentation. The guy, Kurt, behind this framework, is invested in making really good C# API and documentation. So I think this is a great tool. And I'm almost angry when I use Scala, which I use at work. So I don't have such a great framework. There is ScalaCheck, but I don't think it's as good.
Yep. Yeah. So, as you pointed out, a lot of the listeners may be .NET developers. I'm a .NET developer. Can you do this sort of testing in other languages? Do you know? Are there frameworks and tools out there to help them do it in whatever language that they may be using?
Apart from .NET?
Yeah.
Yeah. So there are many implementations of this in many languages. So on .NET, I would say the best framework is fscheck. That's my opinion. If you run Scala, which I do at work, there's something called ScalaCheck. In CPP, I forgot the exact name, but it uses ++. There is a very good framework from Spotify, which I think was excellently done as well. And for Haskell, which is kind of the root, the source of all these QuickCheck frameworks, there is something called QuickCheck, which is kind of the foundation of everything.
Sure.
In general, I think, so for almost every language, you can find a property-based testing tool. They might be different good. I think fscheck really is good, but there are frameworks for almost any language.
Okay. So I think we touched on it a little bit already, which was putting these tests as part of my build pipeline. Is that something that you would recommend doing?
Yeah, I do that at work, and I think you should do it. This is a tool to sort of help you give confidence that your software is working. And we use ScalaCheck at work, and I put it into the build pipeline, and I don't think about it. I think it's if it discovers an error, I'm happy if it does for me. So I think it fits very well in the build pipeline.
Sure. And we recently had another episode on testing, which was integration testing. So we're definitely building up quite a tool belt of testing frameworks. So we've got unit testing, we've got integration testing, property-based testing, functional testing, end-to-end testing, automated UI testing. So I think that build process, as fast as it's becoming, I think we're slowing it down by putting more testing in there. But that is a good thing, because the code that we're producing is going to be much better, much more robust.
Yeah. So if you let's make a slight digression here from property-based testing tool. When I work at sort of companies like Ericsson and Microsoft and Schibsted in some sense, it sometimes makes sense to sort of in Travis put fast executing unit tests that are kind of smoke tests for your general functionality. But then, of course, you need this, integration testing and this scenario testing that actually runs on maybe specific hardware. But if they take hours or days to complete, it might make sense to run them out of band of your build process. But you need to do it automatically. You want to do it automated, but you might not want to do it for every commit, if you know what I mean.
Yes, yeah.
If you can then do it a few minutes, I would definitely try to run as much as possible into my build pipeline. This is what Ericsson we talked about, moving a test to the left. To the left is like closer to the developer, and to the right is closer to the customer.
Yeah. I guess you would set it up to run maybe on a build that was just about to go live, just to do the final big sanity check on the code, because you would hope that by that point everything was covered. But if you're working in an agile environment where you're doing continuous delivery and continuous deployment into live, that could be a problem for you, I guess, with this, due to the time that it takes.
The good for property-based testing tools is that they are fast.
Right.
They are unit tests, and they execute quickly. With integration testing and scenario testing, as you described, they typically, in my experience, are slower. But in this specific context of property-based testing tool, I have no problem putting them, as close to the developer as possible. Let them run it all the time in the sort of Travis. It doesn't add to the build time, I think.
Right. Okay. Cool. So, do you have any suggestions about where listeners could go to find out more about property-based testing? Maybe start learning how to use it and implementing it in their own projects?
Yeah, I thought a little bit about that. And since we are mostly, I think .NET developers listening, I think the FS check documentation. I hope we can put up a link, perhaps, for this.
Yeah, we will stick the link in the show notes to FS check. Yeah.
Great. I think FS check documentation is a great place to start. It describes sort of some simple test cases and how to get running. There are F# code samples, but there are also C# code samples side by side. So it caters to both the F# developer and C# developer. And he also describes some general principles on sort of property-based testing, and some tips and tricks on more advanced concepts like maybe oracles or sort of test models and these kind of things that can help you out.
Yeah. Okay.
For the interested developer, looking back into history of quick check can also be a good idea. But if you want to just get started, FS check, a NuGet package, and start writing some sort of property-based testing, property-based tests from examples, I think is the best way to start.
Sure.
And start small, I think, is a good way. I mean, when you get into this first time and you start thinking, boy, I'm going to write a really advanced test. No, write something simple that you understand. And then you get more and more refined, and you start writing more and more sort of clever test cases that give you more and more confidence. But, we have to start small. This is a new concept that can hurt your brain a little bit in the beginning. And then you realize it's super simple.
Sure. Yeah, I think when you come to a legacy application, trying to put the likes of unit testing and things in can be very painful, especially if the software is not designed quite right. But I think because of the way that this works, I think where it slots into like the testing family, that if you are looking at doing property-based testing, you've probably written your code in a way that facilitates unit testing already. So from what you're saying, I guess it's very easy then to start slotting in property-based testing for those other applications. It's not something that you need to do from the very get-go, very start of the project.
If you have unit testing in place, you're much better shape. A tip, though, which I would like to give your listeners, is that it can sometimes be difficult to identify properties. And when I say properties, I talk about behavior, right? There's the property-based testing. We don't talk about C# properties. We talk about behavior.
Yep.
And a cheat trick, a way to sort of cheat in property-based testing tool is to use something called oracles. And that way, the way that works is that sometimes you might want to write an implementation, perhaps for performance. It needs to be really performant, but because of the performance demands, the code gets complex. And you start wondering, does it really work? But perhaps you can implement a functional equivalent solution that behaves the same functionally but has worse performance characteristics. Well, you can use that implementation as an Oracle implementation that, given any random input, the test case is then, well, if I put this input into my Oracle implementation and I put that into my efficient, quick implementation, the answer should always be the same. So, and that is kind of a way to cheat in sort of, randomized testing and property-based testing into application without having to do a brain burner if you work on a complex project. Sort of, what are the properties? I think that's a good challenge to think about. But using these test oracles can be a great way to cheat a little bit to get testing.
Yeah, definitely. It's something that I hadn't really heard of before until you suggested it as a topic to come and talk about. And I think I've said on the show before, I sort of time box myself, give myself an hour or so to go and have a bit of a brush up on the topic and get to a point where I just know enough just to be dangerous with the questions.
Yeah,
and yeah, it ticks something off in my head with the testing frameworks and how this could be very, very useful. And I think on the next project that I come onto, I think it would be something that we probably look at implementing. I think it's got some good potential here, and I quite like the idea of it.
And I mean, I think a good way is to start small, right? You pick maybe a sub part of your project, saying, here is why I would like to use it. A simple library perhaps, and then you add these tests there. Because I think this is a concept that I know that some people have tried to apply it, they heard about it, and then they struggle. Find something where you think this fits, and some code that really has to work, right? You just cannot afford it to fail. You won't have good coverage there. I think that's a place you can start applying property-based testing. I use it sometimes when I develop libraries where I don't really know exactly how it's going to be used. I need to handle all the input cases, basically.
Yeah. And when I do get to grips with this and have a play, I will undoubtedly be in touch to say help.
Yes, you should do that. Definitely. I think I have many examples. Unfortunately, I cannot show this during this talk, but I have many examples of things that have gone well and things that gone bad.
Sure. Awesome. So we shall include links to everything we've talked about in today's show. So you guys can jump in the show notes and go and learn a little bit more about property-based testing. Maybe you've got an opinion on it. You can jump into those show notes and say that Martin's talking rubbish. But let's have a discussion about it. It'd be fantastic. We're just about out of time, so I would like to thank Martin yet again for being a fantastic guest and coming on to talk to us about a topic that I didn't really know much about, to be fair.
Great to be here, and it's great to sort of spread the love of property-based testing.
Yeah, thank you very much. And thanks to everyone out there for listening to The Cynical Developer. I'm James Sludott, and you've been listening to Martin Rånge talking about property-based testing. Be sure to check out our sponsor, JetBrains Rider, a fast, powerful cross-platform .NET IDE. Build, run, and debug ASP.NET, .NET Core, Microsoft.NET, or Unity applications. Take it for a free 30-day trial by going to cynicaldeveloper.com/rider. If you have any questions about this or any other episode, then drop us an email, a tweet, or leave a comment on the website where you can find all the resource links, show notes for each episode. And if you enjoy this episode, please leave a review on your favourite podcast platform, iTunes, Stitcher, whatever it is, and help The Cynical Developer to reach more developers around the globe.